Okay. Lovely computer technology. See if she's here. There's Joan. Oh, Joan. Let's see. Can we do it in chat? Where's my chat? Chat. Okay, let's see if she comes back. Or actually, let me see if I can dump her into the waiting room and bring her back. Oh no, she's gone. H-I-J-I-I-I. I think she's gone again. Okay, Laura's here though.
Hey Arnold, sorry, I don't know what happened. What's going on with my internet? I keep going in and out.
Okay, you can see what problem did you have problems with, Joan?
Okay, for starters, is number 1.947?
No, according to it's supposed to be 0.514.
Okay, so let's start there, because if I don't even have that one right, then for sure.
Okay, so this one, all you would do is, this is a straightforward one. So you're given the molecular weight of glutamate 146. So calculate the number of moles in a 75 gram sample. So start off with what you have, 75 grams, and then just 1 mole. So the assumption here for all of you guys, right, is whenever you see the molecular weight of anything, the molecular weight of any molecule is equal to 1 mole of that molecule, okay? And so grams cancel, moles survive. And so it would just be 75 divided by 146, which should be 0.514.
And so what I did was I started with what was given, which was 146 grams over 1 mole.
Yeah.
Then I multiplied it by blank on top. And 75 grams on the bottom.
Yeah. Well, again, okay, so that's where, yeah, so you, in this case, the given isn't what you start with. The given is just, again, the whole idea for any of these problems is whenever you have the molecular weight, just always do this. So in this case, I would always write it either this way, and if you're not familiar with it, always write it this way as well, where you put, you have to express everything as a fraction. So express it as either the grams or the moles on top. And remember, whatever your salt, so in this case, the key point here is calculate the number of moles. So moles has to be in your final answer, okay? And so the way you'd have to do it, so if I want moles into my final answer, so if we were to tackle this backwards, let me get these people into, there's 4 more peeps. We're 4 more peeps. And so in this case, Joan, if we were to go ahead and erase this first part, okay? So the whole idea is, if we know we have to get our answer in moles, okay? Because that's what it's asking you for. It's asking how many moles, or calculate the number of moles in a 75 gram sample. So depending upon how your brain thinks about it, we need to know, we know that the moles has to be in our final answer on top. So the only way we can get moles on top utilizing the given is we have to now put 1 mole over 146 grams, right? So we know moles in our final answer, and the only way to get rid of grams is to put the 75 grams on top, so the grams cancel out. And that's where we isolate the unit to be in the final answer. So it just depends upon how your brain thinks about it, because the basic problems always, guys, is you're always going forward, right? You're always working from left to right. And so here is one given parameter.
Yeah.
And then here's the, let me go ahead and mute because I'm getting some background. And then here's the other given parameter right here with what you're starting, okay? And then the answer is going to be on the right-hand side of the equal side. So literally all you have to realize is whatever unit has to be on top here has to be the last one standing on this side where you're doing all your fractions, okay? And that's really the key rule. If and again, this is why the last problem is the hard one, because I'm giving you the final answer, and then the variable, you're trying to figure out what the variable is on the left-hand side. So that's why it's the harder problem, because I'm forcing you to go backwards. In all of these first three problems, you're always working forward. You're given something, you're given the molecular weight, and then you have to come up with the appropriate moles or grams or moles over liters or millimoles over liters. Does that make sense, Joan? Is she still here with us again?
Oh crap, I was muted, sorry.
Okay, no problem.
Yeah.
Okay.
I just did it what I was given first, and that's how I started off, but
Gotcha. Okay.
it makes sense. I mean, yeah.
Okay.
Can we do it on number 4 then?
We can do number 4, yeah. So let's go to number 4. Okay, so number 4.
That was the one I was questioning too, Arnold.
Yeah. Yeah. So
can I actually like try to see if I could get it, like the thing, and then you correct me if I'm wrong?
Go for it. Tell me what you tell me what to write down, and I will write it down, okay?
Okay. How many milligrams of glutamate was dissolved in okay, 0.054 will be at the end.
Yep, so equal.
With, yeah, equal. And then decimolarity, just DCM.
Yeah.
And then glutamate, the molecular weight of. All right, so then it'll be 25 centiliter CL.
Top or bottom?
In the bottom.
Good, 25 centiliters.
And then on the top will be blank.
Yeah.
With milligrams, mg.
Yep, X milligrams, that's our variable, correct?
And then it'll be times 1 mole over
you could do
146 grams.
Okay, you can do that.
And
now,
then times 1 gram over 1,000 milligrams.
Okay, so far you've now taken care of those 2 units right there, okay.
And then 1 centiliter over 100 milliliters.
Nope, that's because now you're getting milliliters, but it's always expressed.
Oh no, liters.
So no, but in this case, yeah. So in this case, it'd be 100 centiliters on top. Okay.
Oh yes, equals 1 liter.
1 liter on the bottom. Yep. So this should be 100 centiliters over 1 liter. So centiliters cancel. Now see, liters. Can't draw my circle today. Liters is isolated now. Okay. So you know you've set it up properly because you got the liters isolated. Okay. And so now, what's the last unit you have?
And then the decimal. And then it would be decimiliters. So 1 liter?
Not 1 liter.
No, milliliter. No, deciliter.
Oh, you got moles that you have to get rid of. So what should be down here?
Oh, mole.
Okay.
A decimal?
A mole or a decimal. If you want to cancel out the moles, what has to be down here, Joan?
A mole.
Oh, yeah, a mole has to be down here. So the moles cancel. So what should be up here then?
The decimal.
Yeah, the decimals, because now decimals is isolated. So now you set it up. And now what numbers go in front of each of these units now?
10.
Yep, 10.
And then 1.
There you go. So now you've set it up properly. And now all you have to realize is because everything is canceled out appropriately, you just keep the X here, right? So you isolate the X. So you're just solving the X for everything, right? And so if you were to do it the way I would teach somebody how to do it, what would I be writing now to condense everything down?
Mm,
And do it very sequential. So I'll start you off. X over all of this is equal to 0.054 decimals per liter, right? And so what should all be here? What should all the numbers be? It's just what?
Isn't it just 1 times 1
110.
times 100 times 10?
Right? Because all the units have canceled out except for, to be proper, because remember, I want to make, because again, for everybody who isn't as confident with these problems, always leave the units that haven't been canceled because you'll still see how it works out at the end. So everything is canceled except for decimals. So it's just X times 1 times 1 times 100 times 10 decimals, and then 25, right?
146.
1,000, 1 liter, and 1, right? So now we've basically we've just condensed this down, right? We haven't included any of the units. We've only included the units that have remained standing. But this is important for the final answer because now if we want to isolate the X, right? X is now equal to a bunch of stuff, right? And so the whole idea is all of this stuff multiplies by 0.054. So right, when you're dealing with the X, equal sign, Joan, it's cross multiplication, right?
Yeah.
So X is equal to now 0.054 decimals. And technically we express this as over 1 liter, okay? So that's it. But now all of this junk comes to the top over here. So it'd just be 25 times 146 times 1,000 times 1 liter times 1. And that's important because now the liters cancel out, right? And over here, these ones divided by 1, divided by 1, divided by 100, divided by 10 decimals. And the nice thing is decimals cancel. And then now you just punch in all the numbers into your calculator. But the thing is, and this is a cardinal rule for everybody who does a problem, if you really want to make sure that you set everything up, cardinal rule is units have to cancel appropriately. If you do not get unit cancellation, you have flip-flopped one of the units somewhere, okay? And that's always the hardest thing. But that's the cardinal rule. You know you've set it up improperly if your units don't cancel out properly. And then what? And then the key thing that Joan made a mistake on is always remember, this is where the only numbers that I ever make you memorize literally, other than the numbers in a formula, are the prefix representations for the metric system. So 100 centis, 10 decis, 1,000 milligrams, and the only opposite one is kilo, right? 1 kilogram is equal to 1,000 grams, or 1 kiloliter is equal to 1,000 liters, and so forth. But basically, there's 4 key metric system prefix values you have to commit to memory. And that would be it. As long as you got those down, you know, and I think the hardest thing for anybody is you just get used to using them if you do it more. Like I said, favorite example in lab is I would go up to Joan and ask, hey, Joan, would you give me $4 for 1 quarter, right? I got the numbers there, but no, I put the numbers on the wrong side of the equal side of the fraction, really. And but the only reason she wouldn't make that exchange is because she knows money. And in this case, you guys have to be as confident with the metric system as you are with money, literally. Yep. But that's what makes this problem difficult because you are given the final answer here. But regardless, if you know the way, if you see how I set it up, all the units cancel out where you are just solving for the X value of this in its true numerical form. So, and it's just practice.
You only have one of those on the exam, right?
Yeah, I
Just
probably
one.
I'm going, like I said, I didn't get too many responses, so I'm looking at about 30 minutes is what I'm giving you for 11 problems.
No.
Nobody has gotten back. So far, the longest person, for everybody who got back to me over spring break, the longest it took anybody was 30 minutes, I think. That's the response I got, so.
I just looked at problems 1 through 4 earlier, and I was already at like 13, 15 minutes, and I was like, I don't think I got the setup right.
Arnold, for this problem that
Uh-huh.
Joan is going over,
Yeah.
you have the given of 0.054, the decimolarity.
Mhm.
We
Mhm.
always go off of that answer. We don't have to solve the problem in the first step.
No. Mm-mm. Mm-mm.
Okay, because that's what I was doing, and the answer wasn't coming out 0.054. And I was like, I don't know, what am I doing wrong? But
Because these first four problems are not linked together. They're totally independent of one another.
okay.
Yeah, they're totally independent.
So noted. So
Yeah.
you're given the number, go off of that number. Okay.
Exactly, whatever is given in the problem. Now, if you look at the BMR problem right below this, that's the sequential problem because
Yes.
you know the STP is separate, the surface area is separate, but the last three steps are all sequential. You have to do number 3 right, apply the STP to get number 4, and then carry the answer from 4 into number 5 to calculate the final BMR. So those are the linked problems. And then technically the last two problems on this page, 10 and 11, those two are linked because 10 to 11 just asks you to convert molarity into osmolarity, right? It's more specifically milliosmolarity. So what makes it technically harder is I'm asking you to do a two-step problem, to do a two-step process to go from 10 to 11, right? Here's the molarity in 10, but what is the milliosmolarity in 11, right? So you have to do the milli conversion and then do the proper osmolarity conversion for the appropriate salt.
I think on exam A, you did a 3-step for a problem like this. But yeah, you it was like a tricky one. Like you had to try to already predicted that the number 11 was going to be a 2-step.
Okay. Yep.
So.
Arnold, do we still have time to go over 11?
Yeah, we have time. We have.
And possibly 10.
So 10. So that's sequential. So let's go through 10 first.
Okay.
So 10 is just a molarity problem, okay? Because it's asking you, what is the molarity of a solution, right? So always remember the given part of the molecular weight, that's almost something to ignore first off, because that's just information you're going to utilize in the problem. So the question actually begins is, what is the molarity of a solution by dissolving, and that's the nice part, by dissolving 150 centigrams, so 150 centigrams.
That's where I messed up in the first one, because I started with the given.
Yeah. This is just to help you do the rest of it, because here's the actual. So in this case, right, we want molarity, which is nothing more than moles over liter. So that's what molarity is, right? So molarity is moles over liter. So how are we going to get from centigrams to moles and milliliters to liters? Well, remember, I always do the easy stuff first for unit cancellation, because any solution is always expressed per liter. Always take care of the liter first, right? So there you go, right? And then in this case, what would be the next step, Joan, to convert centigrams to moles?
1 mole equals 100
11 grams.
centigrams.
Not centigrams, grams. So we got the grams in the mole, but we haven't got rid of the centigrams. So how do we get rid of the centigrams?
It would be 1 gram equals 100 centigrams.
Centigrams cancel, grams cancel, liters, moles survive, and you are good to go. So it should be 0.034 moles over liter. So that would be for number 10. And then in this case, this is where, like Lenine was responding. In this case, look at continuation of the previous question, just convert your answer to milliosmolarity. So here's the information again, if you need it. So it's the exact same thing, right? 150 into 400. And then, so this is where I actually got this question from Natalie. So I have to be very specific in the way I do this, because why? If we actually do the problem, just FYI, because I got to do get my calculator out. So if we actually take 150 divided by 400 times 1,000 divided by 111 and then divided by 100, we actually get as our answer, the actual answer is 0.03378, okay? So now, for this answer, this is where either I have to be very specific or it will be included in the range, right? if we want to just take this answer, it'd be 0.034 moles over liter, correct? And now we just have to convert your answer to milliosmolarity. So milliosmolarity would just be now 1,000 millimoles per 1 mole. And then because it's calcium chloride, what is the milliosmol to millimole ratio then? What number should go here?
3.
3, yeah, 3 to 1, because calcium chloride will divide up into 1 calcium divalent, 2 chloride ions, so everything cancels out appropriately. And so, of course, 0.034 would just be 34 times 3, which would be 102, I do believe, is the final answer. Or in this case, I put down 101, because if you do this, 0.00378 times 1,000 times 3, it is 101.35. So if you carry this answer over, it'd be 102 if you actually did the entire problem and then multiplied this value, right, by 1,000 by 3, you get 101. And so just realize, guys, if you, since I made the quiz, right, if you now look at my final answer, I think it shows it to you guys. Oh, it doesn't. But if you were to go into my key, the correct answer would be 101 plus or minus, I think, like 2. So it does include whether or not you continued through the problem and got 101, or took answer to number 10, multiplied it by just 1,003 to get 102. And so usually what will happen is that the question will give you very specific instructions. If you follow them, you should get my number. If you don't follow them, you should still get it right, because there will be a range. And so in this case, if I see a number like this, I calculate this as the base value. So I would actually carry this through to get 101. But then if I just continued this step here and get 102, the correct answer on my key would be 101 plus or minus, I think, 2. So as long as you put down 99 to 103, you'd get it right. Okay. So there is a range to take into account minor, if you want to call it rounding errors, if you want to call it, okay, but your rounding can't be so aggressive that you are out of my range. And remember, all the questions will say you can only round at the end of your computations. You cannot round every step, or in that case, the range would be very, very broad. Okay, so just FYI there. So, okay. But there you go. So does that make sense, Joan?
Yeah, more than before this Zoom. Okay. Also, I sent you an email. Did you on my Canvas, it shows that I was missing those 3 points.
I will check, but don't worry. As long as you sent things to me, I'm not worried about it, because the Canvas gradebook's all screwed up anyway already. So, but I will check. If you sent them to me and you got it for me, that's all you care about. Okay.
Okay.
So as long as you got it for me, then you're fine. Don't even worry about what's on Canvas.
Okay. I think I did get one.
Okay, good. All right.
Arnold, do we have time to just do one more?
Sure. This might as well just let's take care of all the math stuff first, because I'm in no rush. Let's put it that way. So yeah, go for it, Lenine.
I wanted number 3.
Number 3? Okay.
Mm-hmm.
Number 3. So given the amino acids.
I think that was the email that I didn't get from you. The one that I don't think you responded to, but.
Okay, so in this case, it's just a straightforward problem. We're just calculating the final millimolarity of the solution. So we need millimoles over liter as our final answer, equal sign. So 7 decigrams in 467 milliliters, right?
Yes, correct.
Then, let me get this person in. And then, for me, again, I always get rid of the milliliters or the volume first. So I always want to isolate the liters as the first thing, because that never changes, okay? And then in this case, decigrams to grams, so 10 decigrams to 1 gram. Now we bring in the molecular weight, 146 grams to 1 mole. And then, let me get rid of this equal sign. Oh, get more people in. Okay, and then, oh, darn it.
That's 1 gram over 10 decigrams.
1 gram over 10 decigrams. And
Thank
then
you.
finally, 1,000 millimoles equal per 1 mole. Moles cancel, millimoles survive, and so there. Yep.
Okay, so when I input it in my calculator, I would get 0.1026. I don't know how many times I did the practice exam and it kept on coming out wrong.
Well, so, let's see. Maybe I did my calculations wrong.
Well, that's what happened. Then I did it again. I'm like, oh, I got a different number. So I put that number in, 10.27. I'm like, oh, I remember that one. Okay, let's try it again. So I put all the numbers in. Oh, I got it right. Then I'm like, oh, wait, what did I do? So I tried to go back. And I had a senior moment. I'm like, I don't know what the hell I did.
No, it's supposed to be 10.27.
Okay, so when I input it, okay, Arnold, what did you do? It doesn't come out that way.
No. Okay, I'll walk you through it. So 7, right? 7 divided by 467. Did you do, okay?
Yes. Mm-hmm.
Times 1,000.
Mm-hmm.
Okay. Divided by 10. Okay. Divided by 146. And then times 1,000. You should get 10.27 rounded up. That's what I'm getting.
Shit. Oh, sorry. All right. I'll play with this ding. Okay. Ding, Arnold, I swear.
No, don't usually, okay. This is why, mechanisms of teaching and assessing students. So seriously, this has given me more turmoil than you could ever imagine, because for me, like I said, even though the final answer is important, okay, remember, this is a learning moment, meaning do you understand how to set up a problem, okay? And so, I would see this all the time on your guys' exams. You guys would set up the problem perfectly, but then your final answer would be off like by 1 decimal point or 2 decimal points, or the wackiest ones are your final answer is the inverse of my answer, because you put everything in, you put all the fractions upside down. You know what I mean? Mm-hmm. So for me, whenever I grade these problems, that's why if you notice, I only assign each of these as a half a point each. I don't make one more than another. And then I do some funky, mathematical conversion to convert it to, let's say, 40 points out of 40 points as it contributes to lab exam number 1. Because if we were on campus and you guys would be showing me your work, I assign points to the work. The final answer is only worth a point. So like this problem, just FYI, if this were a real problem that you guys would be taking on campus, this would be a 1, 2, 3, 4, 5. This would be a 6-point problem. Every fraction's a point. The final answer is 1. Let's say like Lenine, right? You set everything up perfectly and you get some wacky number here. Yeah. You'd still get at the bare minimum 5 out of 6 points. You know what I mean?
That just kind of stinks for us right now.
Yeah, it does sort of stink. That's why I have to make these equal weighting. So it doesn't matter whether it's an easy problem or a hard problem. I'm just assigning them at 0.5 points. Then I'm putting them into a mathematical expression to make it equal worth 40 points out of 40 points or something like that. So let's put it this way. You can't blow all of them because you shouldn't blow all of them. But if you make a minor math mistake because each of them are weighted equally, this is where everybody has a good shot of still earning full credit or maybe some extra credit. Okay. Because I just want to see some competency, because you can't screw up on all of them. Let's put it that way. Okay. There's no way that anybody will screw up on all of them. You just make sure you follow the rules. And like I said, when you punch these numbers in, your calculator, because there's no plus or minus sign, this is all just a straightforward problem. You don't, again, as I type it into my calculator, right? Just 7 divided by 467 times 1,000, you drop all the ones. But, even if you were to do it 7 times 1,000, right? I'm just doing all the top ones, times 1,000, and then divided by 467, divided by 10, divided by 146, I still get 10.27.
Okay, whatever. Scratch out that email.
Okay.
I left you this long, lengthy, and I think I put, just.
No problem.
Okay, thank you.
No problem, Winnie. But anyway. Okay, guys. So any other questions on the problem set B? Sorry, I can't recreate A because I don't remember what was on A. I think I can put some of the basic problems. I can't put another STP up on there because I'd have to do too much figuring out what the hell Canvas did. but I can put some of these basic chemistry problems back up from A. Anything that doesn't deal with glutamate, I can throw upon as a last minute step. So if you want to see those questions again, I'll post them tonight, okay? But it won't be.
Please, Arnold.
But it won't.
Thank you.
There won't be any BMR on it, okay? It will be strictly, grams to moles, moles to gram, molarity, millimolarity, problems like that. And so I can give you the ones that obviously don't deal with glutamate back up there, but it won't be a full 11 problems, okay? But I can't.
Anything else?
Number 2.
Can I do number 2? Sure. Number 2. Oh, darn it. Number 2. All right, so no glutamate. Well. All right, number 2. So we're looking at straight conversion problem because all we're doing is we're going from 7.8 centimoles, and all we want to do is come up with an answer in milligrams. And so no molarity problem, so you just have to convert 100 centimoles to 1 mole, and convert 1 mole into grams. There you go. Sorry. Grams, and then I'll got ahead of myself. 1,000 milligrams. 1,000 milligrams to 1 gram. Grams cancel out. So our final answer is in milligrams. There you go.
Thank you.
You are welcome. All right, so. I think that's pretty much all the problems except for the BMR one. So, but it's like I said, it's whenever I encounter this, again, it's just seriously, it's all about practice, guys, and you do it often enough, it becomes second nature. But I think, if you're not used to solving a problem backwards, again, one of the biggest things that you guys should remember from your chemistry class, you're given a basic formula like, the ideal gas law, and depending upon, you think about, P's and RT, right? Well, in this case, you're given E and D, you should be able to figure out the T on the back end, but you're given E and D, you should be able to figure out what P is, right? And so whether you go forward or backwards, again, it's just making sure you know what you want to use either side of the equal sign. Go for it, Alyssa.
Can you go back to number 11? I was still thinking about that. Please.
Number 11, sure. And so number 11, it always goes back to what makes number 11 an extension of number 10. But let's just do 11 by itself, okay? So if we do 11, and the first thing we should probably do here, remember, because this is the osmolarity problem, you guys have to remember that when you take calcium chloride and put it in an aqueous solution, it breaks up 1 mole of calcium divalent ions, but 2 moles of chloride. Okay, so this is where we end up with the 3 osmol factorial. Okay, and in this case, if you want the problem to have a proper unit cancellation, well, we could start off with, again, 150 centigrams over 400 milliliters, because that's what's given, right? 150 and 400. We want to convert it to molarity first, so 1,000 milliliters to 1 liter. We got that back in state, 1 gram to 100 centigrams. 111. That's the molecular weight. 111 grams of calcium chloride to 1 mole. Grams cancel. But now we want it in milliliters, 1,000 millimoles to 1 mole. And then finally, 3 milliosmoles to 1 millimole. And the only reason I use these to make sure my units cancel out, but it's literally just 3 to 1 factorial. And so everything survives. So in this case, final answer, milliosmoles per liter has made it your final answer. And then just plug in the numbers you get one there. And so the only real difference in this problem is you're converting it into a final either molarity or in this case millimolary form. But the whole idea is when you now have to convert it to osmoles, right? Osmolarity or deciosmolarity or whatever, you have to take into account the association of the ions into whatever factorial it may be.